Good morning, sir. We are going to explain the software design for online ticket reservation system, and our teammates are S. Bharat 188209, Navin Raj 188232, Nitin Christopher 188235, Vijayan 18436, and I am Navin Raj. I am going to explain the introduction and use case diagram and class diagram.
The online ticket reservation system is a web-based application system that works with a centralized network. By using this ticket reservation system, through online people can book tickets for bus, train, aeroplanes, movies and etc. The passenger can reserve the ticket by giving the required details in the form and submit it for processing. There are restrictions in some of the booking kinds, that is, you can only book upon 6 members of air and maximum 10 people for bus. The administrator will control the ticket reservation and the accounts of the passenger who are signing up in our website. The administrator can reset the seats, fares of the ticket and generate the PNR number for the ticket that is reserved. The sole control of the system is handled by the administrator. The printer prints the ticket that are reserved by the passenger. The passenger can sign up for only one time and he can sign in for any number of times for reserving, cancelling and viewing the tickets. The cut-in fare will be made according to the age of the customers. There will be the deduction in the fare for senior citizen. The system tracks for the database any number of time for reserving, cancelling and status viewing. The passenger can see the status of the class that are available in the mode of travel they choose in which he is going to travel by noticing the number of seats details from the display board. The cancellation of the tickets is also very easy so that the passenger can cancel the tickets that he has booked. But some of the return fee will be charged for late cancellation and any type of cancellation before the day of travel. And now let us talk about project scope. The online ticket reservation system has 4 stages of performance. The first is login stage where the user can log in with their own username and password. And the next stage is searching for type of reservation like train, bus or for a movie and searching for availability of seats. And the third stage is booking of ticket using GPay, PayPal or Paytm. The last stage is to cancel the reserved ticket with the rules and regulations followed. And this is the use case diagram for our online ticket reservation system. This use case diagram is a graphic depiction of the interactions among the elements of ticket reservation system. It represents the methodology used in system analysis to identify, clarify and organize system requirements of online ticket reservation system. The main actors of the ticket reservation system are the customers and administrator. Relationship between and among the actors and the use cases of ticket reservation system is shown in this use case diagram. Here there are two agents, one is customer and another one is administrator. The use cases of customer are login, managing the type of reservation, cancellation of ticket, checking the availability, booking the ticket and make payment, printing the receipt and asking for refund. On the other hand, the use cases of administrator are manage booking, manage stations, manage passengers and manage fare, checking payment and checking for cancellation and refund.
The class diagram in the unified modeling language is a type of static structure diagram that describes the structure of the system by showing the system's classes, their attributes, operation or methods, and the relationship among objects. The main purpose of class diagram are to show static structure of classifiers in a system. And the class diagram is made up of set of classes and set of relationship between classes. A class is a description of group of objects all with similar role in a system which consists of structural features and behavioral features. A class notation consists of 3 parts: class name, class attributes and class operation. Here the passenger class has 3 attributes and 6 operations. We have 6 classes: payment class, ticket class, passenger class, ticket clerk class, train class and railway database class. Each class have their unique attributes and operations. A class may be involved in one or more relationship with other classes. And the multiplicity is how many objects of each class take part in the relationship. And multiplicity can be expressed as exactly one, 0 or 1, many, one or more, exact number or a complex relationship. In this class diagram, we have 5 types of multiplicity relationship. They are passenger payment multiplicity, passenger ticket clerk, passenger train, ticket clerk railway database, passenger ticket. There is a 0 or 1 to one or many relationship between passenger and payment, and one or more to exactly one relationship between passenger and ticket clerk, 0 or 1 to one or more relationship between ticket clerk and railway database, 0 or 1 to one or more relationship between passenger and train, one or more relationship between passenger and ticket. For example, the one to one or more relationship between passenger and ticket implies that the ticket can be booked only by one passenger, but a passenger can book more than one tickets. Like that, the 0 or 1 to 1 or more relationship between passenger and train implies that the passenger may or may not book a train, but the train contains more than one passenger. And now we are going to see about sequence diagram. A sequence diagram shows object interaction arranged in time sequence. It depicts the object and classes involved in the scenario and the sequence of messages exchanged between the objects needed to carry out the functionality of the scenario. Sequence diagrams are sometimes called as event diagrams or event scenario. The passenger first need to log in to the system, and the railway system validates the login and return the status to the passenger. Then the passenger requests the form for online ticket booking. Then the railway system create a form and submit it to the passenger. Then the passenger submit the details and the railway system create a ticket and send details to the admin. And the admin validate the details and creates the ticket. Then the railway system acknowledges the passenger that the ticket is created. Then the passenger take a print of the ticket.
Hello, I am Bharat. My roll number is 89209. So I am going to explain about the following diagrams such as collaboration diagram, state diagram, activity diagram and component diagram. So first we start with collaboration diagram. A collaboration diagram is also known as communication diagram. It is an illustration of relationship and interaction among software object in UML, that is Unified Modeling Language. So these diagrams are used to represent the sequence of messages that are flowing from one object to the other object. So now the four major components of this collaboration diagram is objects, actors, links and messages. Object is nothing but it is represented as an rectangle boxes, what you see in this picture, and some name is labeled inside this rectangle box, which is nothing but a class name. So while we coming to actors, actors are instances that involves the interaction in the diagram. Each actor has a name and role with the each actor has a name and a role with one actor initiating the entire use case. So while coming to links, links are connections which connect the objects and the actors and depicted using a solid line between two elements, like what we saw in this picture. A line is linked with between the passenger and the railway system and railway system and the ticket. So these are the links. So each link is an instance where message can be sent. So last is message. Message between objects are shown as labeled arrows placed near the link. So that is like arrows which is shown between the passenger and the railway system, and between railway system and passenger another arrow is shown there. So these messages are communication between objects that convey information about the activity and can include the sequence number. So next thing is state diagram. So state diagram is a type of diagram used to describe the behavior of the system. So state diagram requires the system that describes the components and composed of finite number of states. We use this state diagram which is responsible for change in state to understand the reaction of the object. So while looking into the basic component of state diagram, the initial state, the transition state are the main important components of this state diagram. The initial state is filled with the black color which is represented in the picture, like filled black one, that is like bulletin. And the transition state, we use a solid arrow to represent the change from one state to another. The arrow is labeled with the event which causes the change in state. Like an arrow is represented from a black dot to search train option, and from search train to the check ticket availability option, and etc. So we use a rounded rectangle to represent a solid state, like which we shown in the picture. A rounded solid is shown for each and every object, for search train, check ticket availability, logout, book tickets, and etc. So next thing is, finally we use the filled circle within a circle to represent the final state of the diagram, like which is shown in the logout. Next to the logout, a circle is filled inside the circle. So like first a filled circle is a starting point, then we search for train and we search for ticket availability. If yes, it continues. If no, we should log out. So final point is the circle inside the circle. So this is the end point. So this is about the state diagram. Next thing is activity diagram. So the purpose of activity diagram is to describe the procedural flow of action as part of the larger activity. So a larger activities is shown in the procedural flow, which is known as activity diagram. So here basic component of activity diagrams are a small filled circle, like we shown in the state diagram. It's the starting point. So edges and paths illustrate the transition from one action state to another action state. They are usually drawn with an arrowed line. When an activity requires a decision prior to moving on to the next activity, a diamond is added between two activities. Like, so in this picture, user logins, and next thing is authenticating. So if it is a valid authentication, it will go to the next stage. If it is not a valid authentication, it will go to the invalid state, which is shown in the diamond shaped thing. So this is responsible for the decision making point. So a merge event brings together the multiple flow that are not concurrent. So an arrow which is shown in the picture pointing to the filled circle nested inside another circle represent the final action state. So as shown in the state diagram, the final state is represented the circle filled inside the circle. So this is about the activity diagram. The last but not least is the component diagram. So component diagrams are used to model the physical aspects of the system. Component diagrams are used to model the physical aspect. So physical aspects are the elements such as executables, libraries, files and documents and etc., which resides inside a node. This diagram is different from other diagram. It does not describe the functionality of the system, but it describes the component used to make these functionalities. Like if you want to log, there is a train document called train, and it is connected to the RRS database, railway reservation system database. So this database requires zone file, search train file, reservation file, ticket file and etc. So we have to consider something before drawing the component diagram. That's our the things are files, libraries, visuals and etc. Files used in the system are responsible for the component diagram. The libraries and other artifacts relevant to the applications are required. Relationship among the artifacts are required. Creating a visual for each of the component is must-be in this component while drawing the component diagram. So next thing is describe the organization and relationship between the components using interfaces, ports and dependencies. So these are the requirements of the component diagram one should consider before drawing this component diagram. So until then my part's finished. So next will be I mean, next thing will be followed by Nitin Christopher. Thank you.
Okay, good morning, sir. My name is Nitin Christopher. My roll number is 189-235, and now I will be presenting to you my part of the assigned presentation for software engineering. My topics for the presentation are deployment diagram and forms. And now let's start with the deployment diagram. So, what is a deployment diagram? A deployment diagram is a diagram that shows us the configuration of the runtime processing nodes and the components that are part of the system. They are used in modeling the physical aspects of the object-oriented system, and they are also used in the topology of the hardware. And what is the purpose of a deployment diagram? The purpose of a deployment diagram is to show the structure of the runtime system, and it also shows uh, the different links between the hardware in the system, in that system, okay, and how they're linked with each other. And they can also these deployment diagrams can also be used to plan the architecture of the system. And here in the deployment diagram for our example of an online ticket reservation system, that is the railway reservation system, we have the railway server that is right here, and we have a modem which connects the railway server to the internet, and then we have the console node which has the executable file reservation.exe, which is linked to the railway server. The railway server is it runs on the server software Apache with operating system Windows, as you can see, and that has other specifications such as memory and all. And then we have this console here, which is connected to the railway server that has the user data and fare calculate fare executable files. And this is connected to the printer. This is the node that prints everything. Okay, and here it says that deployment diagram consists of nodes which describe the CVS. So each node, each 3D box here, represents a node, which is a physical device. And so the component diagram, which was previously explained by Bharat, is derived from our deployment diagram. So moving on to the next slide, we have forms. Okay, so forms. What are forms? Forms are a layout of different various inputs and input types to accept information from the user, and with that information we can do further things, but the main use of form is to accept information. So during the designing of a form, so the designer should know that who will use them. So this is very important, as it can help us in designing the layout of the form. So in case our target audience is senior citizens, then our layout should be simple, very simple. It shouldn't have a lot of complexity, as the old people are not very accustomed to modern technology. So the designers need to know the people, the target audience, and next, where would they be delivered? Would they be delivered to offices or schools and all that? And the purpose of the form. The purpose is what the form. Now we come to the objectives of a good form design. Okay, the first one is to keep everything simple and in a proper sequence. So say we're collecting data about a user. We start by asking their name and their roll number, or their email ID and so on and so forth. We shouldn't start by asking their address, residential address, or their PIN code or whatever. So and each input field should have a proper caption. So prompting the user to enter the right information. Next, we have to use forms. We have to use uh, forms that are intended for the correct situation. Like if you want to use forms for a student group, then you have to use a then we have to have the appropriate form that is designed for students in that purpose. Next, we have to ensure that the form is completed accurately by the user. So we should make sure that the form is simple enough that the user doesn't give redundant answers or give different answers for the same question or the same input. Okay, and next we have to keep the forms interactive and attractive. So how this helps is this makes the user finish the form instead of being very put off by the form. So an attractive form usually attracts the users and makes them complete the form very easily, very quickly. And this and next objective of a good form design is to have navigations, to have good navigation between this and that, between these aspects and that aspects in the text form or the previous form. And now going to the next slide. So here in forms for online reservation, we have here we have a few snapshots from our presentation, which are from our application, which is for online railway ticket reservation. So the first form number one here, right here, is used for is the welcome screen. This is the first form that you'll see. So here you have details and exit. So if you hit details, you go to the next form, and if you hit exit, you just exit the software. And then once you go to the details, we have a form 2. You have train details, reservation cancellation. Train details is for all the trains that are available. Reservation is to book the available trains, and cancellation is to cancel the already booked ticket. And we have exit. So when we hit train details here on form 2, we go to here this is form 3, which is train details, and we have the name details of the trains to be specific. So these are a few snapshots from our test case, and with this we come to the end of my segment of this presentation. Thank you.
I am Ajayan. My roll number is 99436. Today we have to discuss about online ticket reservation, and my topic is black box testing. Testing is defined as the application to the coding to be tested. One application is to be tested, that is known as testing. Now we can discuss about black box testing. Black box testing is a powerful technique to check the application under the program to user perspective. Second one, this testing approaches focus on the input to the software. That means that software is given to the input and the output should be produced. Third one, technique of a software examines functionality of examines to be tested in this black box testing. Second slide, various methods of black box testing. Methods: manual UI testing, automated UI testing, documentation testing. First we have to see about manual UI testing. A tester check the system user and check verify data error message. That means the user can check the verify data to be error message. That is known as manual UI testing. Second one, automated UI testing means user interaction. That is known as user interaction automated UI testing. Then recorded to be find error and glitches. Glitches means functionality error. functionality error or multifunctionality error, that is known as glitches. Third one, tester can set record demand as per scheduler and manual approaches to the testing. Documentation testing means tester purely checks and input and output of the software. Tester is purely checks and input of the software, then perform rather than, that is known as documentation testing. And technique involved on black box testing methods. First one, identification of equivalence class. Second, generating test cases means to generate the test cases. Third one, boundary values of analysis and the cause effect graphing. That is known as techniques involved in black box testing.